Sample problem, type 2 projectile. An arrow leaves a bow at 30 meters per second at an angle of 30 degrees. Letter A. What is its maximum range? Letter B. Find the maximum height reached by the arrow. Letter C. How long would the arrow take to land on the other side exactly opposite where it is launched?
Okay, now let us illustrate the problem. So we have an arrow projected with an initial velocity of 30 meters per second at an angle of 30 degrees. Now let us identify the given. We have the following. Your initial velocity is 30 meters per second. Your angle of projection is 30 degrees. The acceleration due to gravity is 9.8 meters per second squared. Now, let us find what is being asked in the problem. For letter A, it was asking for range or dx. For letter B, it was asking for height or dy. And for letter C, it's asking for time or the total time taken by the projectile. Now let us solve for letter A. So what formula are we going to use to find your range or dx? We can use this one. Dx is equivalent to vi squared sine 2 theta divided by g. Now we can directly substitute because we already have the following. Your initial velocity is 30 meters per second squared sine 2. Your theta is 30 degrees. Yan. So, divided by 9.8 meters per second squared. Let us compute. 30 squared is 900 meters squared per second squared. Then sine 2 times 30 is 60. Then divided by 9.8 meters per second squared. So first, let us solve this one. Click sine 60, then equals, then multiply it to 900, and that will give you 779.42 meters squared per second squared. Then divide it to 9.8 meter per second squared, and that will give you, so since we already have the answer, we can now divide it to 9.8, and that will give you 79.53 meters. This is now your dx or your range. We can now solve for letter B. Let us find your height or dy, and we can use the formula vi squared sine squared theta divided by 2 times acceleration due to gravity. And we may now substitute here. Your vi is 30 meters per second squared sine squared, your theta is 30. So divided by 2 times 9.8 meters per second squared. Now we can calculate. 30 squared is 900 meters per second squared sine squared times 30 divided by 2 times 9.8, 2 times 9.8 is 19.6. Okay, next, let us solve this one. Click sine 30 squared, then multiply it to 900, and that will give you 225 meters squared per second squared divided by 19.6 meter per second squared. Now let us divide 225 divided by 19.6, and that will give you this one, 11.48 meters, because this will be cancelled and this one, and that will give you the unit of meters, and that is now your dy or your height. Let us have the alternative solution for letter B. Okay, we can use the formula VFY squared is equivalent to VIY squared minus 2G dy. But the problem is we don't have the value of your initial velocity along the vertical. So let us solve it first. VIY is equivalent to, we can use the formula VI sine theta. Substitute, we have your VI 30 meters per second, sine 30 degrees. So, click first sine 30, then equals, then multiply it to 30 again. And that will give you 15 meters per second. And this is now your initial velocity along the vertical. Now, for this, as we recall, your velocity along the vertical here at the maximum height is equivalent to 0. And since we need to find your maximum height, dy, therefore we can use this one as your final velocity. Therefore, it will become 0, so cancel na yan. Then, it will give you VIY squared minus 2G dy. To solve for dy, or the maximum height, we need to transpose this to the other side, and this will become negative. So, negative VIY squared is equivalent to negative 2G dy. So next, we need to divide both sides by negative 2g. So negative 2g will be cancelled here, and that will give you dy is equivalent to negative VIY squared over negative 2g. We may now rearrange dy is equivalent to negative VIY squared divided by negative 2g. Now we can substitute. Your VIY is 15 meters per second. So negative 15 meters per second squared divided by negative 2 times 9.8 meters per second squared. Okay, now 15 squared is 225. So 225 meters squared per second squared divided by, we have negative here, 2 times 9.8. 2 times 9.8 is 19.6 negative meter per second squared. So let us divide 225 divided by 19.6, and that will give you 11.48, and this is meters because this will be cancelled, and that will give you meters, and this is now your height dy. So as you can see, for the alternative solution, we have the same answer, with our first solution. So they are the same. We may now solve for letter C. We need to find the total time, and we can use the formula dx is equivalent to Vix times t. This t is already your total time taken by the projectile from the initial position to the final position. So, but the problem is we don't have the value of Vix. Therefore, solve for Vix first, and we can use the formula Vi cosine theta. Substitute, your Vi is 30 meters per second, cosine 30 degrees. So let us solve. Click cosine 30 equals, then multiply it to 30, and that will give you 25.98. 25.98 meters per second. Now, since we have the value of your initial velocity along the horizontal, we can solve for t, but let us derive the formula first. Divide both sides by Vix, so it will give you t is equivalent to dx over Vix. We may now rearrange. Dx is equivalent to t is equivalent to dx divided by Vix. So substitute dx. Your dx is 79.53. So 79.53 meters divided by your Vix is 25.98 meters per second. Now we can solve for t. 79.53 divided by 25.98, so 3.06 and cancel, so seconds. This is now your total time. Now let us find your total time for the alternative solution. Fy is equivalent to Viy minus gt. So now, we're going to use Bfy is equivalent to 0. So, we are getting the time of the projectile from this position up to this position only, because we're going to use this one as your Vfy. This will become negative, so negative Viy is equivalent to negative gt. Next, we need to divide both sides by negative g, and that will give you the formula of t. We may now rearrange. T is equivalent to negative Viy divided by negative g. Okay, now let us substitute the given. Your Viy computed here is 15 meters per second. 15 meters per second negative divided by negative 9.8 meters per second squared. So let us divide 15 divided by 9.8. And that will give you 1.53. Okay, so let us divide 15 divided by 9.8, and that will give you the time of 1.53 seconds. Cancel, 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 and that will give you seconds. Now, as you can see, this one is different from this one. Why? Because this is just half of your time. Because, as mentioned before, We are getting the time only from this point up to this point because we are using VFY. VFY is equivalent to 0. So up to this point only. Therefore, for our final answer here, we need to multiply this to 2 in order to get your total time. So total time is equivalent to 1.53 times 2 equals to 3.06 seconds. Now, they are the same already. So this is your final answer for the alternative solution. Thank you.